Thank you for joining us. This is TechWorks CC2-Series Clinical System Technical Training Part 3. I am Mark Dundas, and I will be your host. A bit of housekeeping before we get started. This is designed to address the design and installing of the TechWorks CC2 series. We assume a basic understanding of healthcare products, meaning we don't think we have to tell you what a nurse call is. This is, as I said, part 3, system wiring. There is a presentation guide handout available online if you'd like to go and grab that and follow along, take notes. There's also a certification test available for installers, and if you complete all 4 parts of the test satisfactorily, TechWorks will be happy to authorize you as an installer, an official TechWorks installer. Let's real quickly talk about CC versus CC2. For those of you that have known our product since 1994, the product has changed over the years. The big change came just a few years ago when we went from CC to CC2. What's the difference? 12-volt DC power versus 24. CC2 is 24. But it will run on 11 to 25 volt DC. CC, the original product, was only 12 volts DC. So what that means to you is CC2 will work on an old CC system, but not vice versa. So if you have an existing system, go ahead and plug a CC2 product into it, should work fine. That connection is exactly the same and you won't know the difference. However, if you are trying to replace an old passive dome light, that can be a problem because the old passive dome lights ran on less power. They didn't have any kind of circuitry in them to deal with different power variations, and the new dome lights require more power. So they probably won't work on your older system if you got an old style system with old passive dome lights. Very quickly, this is about wiring. So we're going to talk about the wire. The following section on programming will talk more about the addressing of the devices. But right now we're going to talk about wire. The main wire for a clinical system is this dashed line that goes from device to device to device, including the annunciators. That is a 2 twisted pair network. So you've got a patient station. You could have a whole lot of them. Okay, this could be a large system with 16 stations. But the idea is that all of these devices are connected on this 2 twisted pair number 18 bus, and then they talk to each other over this bus by identifying themselves with an address. Always make sure to connect your power as close to the middle of that bus or loop wiring as you can. That gets the power evenly distributed over the entire network. In the case of the addressing, these 8 stations go to these 2 annunciators because they're all addressed master 0, master 0, master 0. These stations all go to master 1. It's not how you run the wire. It's how you set the address. So running the wire, just run it from station to station. If you want things to talk to each other differently, you have to change the address. So let's talk about the wiring on the dome light. You've got a network connector. This is where that 2 twisted pair hooks up. And you'll see here that this says 12 volts DC. The new ones all say 11 to 25 volts DC. The data has not changed. It is a twisted pair data loop. The terminator for this resistor, and we'll talk, or terminator resistor for this network, and we'll talk more about this, is right here. So on the last device on the end of a data run, you turn this switch on to terminate the bus to keep noise down on the data network. How things talk to each other is all about the addressing. This also includes the options. This determines what happens when a button is pushed. You hook up passive stations here. So you're going to see in the next slides that this LED plus and minus and switch plus and minus, whether it's station 1, station 2, station 3, station 4, all these terminations are the plus and minus for the switch and then plus and minus for the LED in a passive station. Switch number 1 corresponds to the red light. Switch number 2 corresponds to the yellow light. Switch number 3 corresponds to the green light. And switch number 4 corresponds to the blue light. For hard wiring of buttons, not for network. Anything that's got an address connects over this. Anything that doesn't have this data network connection has to connect to a smart module via passive interface terminals. The 4-button station is the same as the dome light. It's using basically the same hardware on a different circuit board. Again, you'll see the older devices said 12 volts, the new ones say 11 to 25. Here's your network connector again. This is your 4 wires, your 2 twisted pair, your data pair and your power pair. And these are not 4 conductors. They are 2 twisted pairs. That's to keep noise down on the data. Again, the terminating resistor, just like on the dome light or any other smart station. And then your address, which identifies this device to the network. And again, the options. The options we'll talk more about in the next presentation, but this determines what happens when you push a button. That's what those options are all about. It's what happens. Has nothing to do with how it's wired. Again, all you do is wire these devices together, and then you set these dip switches to determine what happens. Let's talk about this marvelous network, because this is really what makes TechWorks CC different than other products on the market. There are 2 major factors in making this thing work very, very well. First is the wire has to be twisted to keep the noise down. The second is proper termination. So at the end of this twisted pair for data, you have to turn on a resistor. You don't have to take a resistor out of your kit and put it under the screw terminals. It's built into the stations, but you have to turn that switch on the last devices. With a TechWorks network, you do not have to run in and out and in and out of all the stations. You can T-tap. You can run this wire in any direction you want, up to 3,000 feet of wire. The key is the longest runs you want to turn on the terminator. So it might be more than 1 terminator per network. You might have 3 or 4. If you've got a splice point in the middle at the power supply, so let's say you put your power supply right here in the middle, and you've got short stubs that go off to switching devices or annunciators or something else, and then you go on down the hallway. You only do this terminator on the longest run on the last station. Talk about passive devices. We make an emergency pull station. As we said in earlier slides, this is not a UL 1069 listed nurse call pull station. It looks like a pull station, acts like a pull station, functions like a pull station for non-code compliant areas where you want signaling, but it's not a code requirement. Here's those magic screw terminals I was talking about. So you've got a pull string or a push for help on our station. They are in parallel. The cancel button cancels all calls from this station. There is a call confirmation light behind the cancel button that tells you this station is active. Your wires hook up to a smart station. Again, this is a passive station. Switch plus, switch minus, LED plus, LED minus. That's all there is to it. And these are not twisted pairs. They could be, but they can be conductors. Any old 4-conductor wire. It could be thermostat wire. We don't care. This is our push for help station. It's the same as a pull station, but no pull string. Again, a push for help, a cancel button, and a call confirmation light. The same exact screw terminals, switch plus, switch minus, LED plus, LED minus. We make a patient station. Again, I can't overemphasize. It looks like a nurse call patient station, but it is not a nurse call. Why under the sun would you want a patient station if this isn't a nurse call? Well, we have applications where a doctor wants a button to call somebody. Has nothing to do with life safety, is not an emergency situation, but the doc wants a button on the wall in the exam room. And in some cases, they have some kind of a table in the middle of the room where they're taking a look at somebody. Again, this is exam space. This is diagnostic medicine. So this patient station is up on the ceiling with the cord dangling over this table where he's looking at somebody. It's just a convenience item. It's the exact same thing as pushing one of the 4 buttons, but again, this is a passive, dumb station. No brains in this station. Has a quarter phone jack for a call cord. It's got a push for help button, which is in parallel with that call jack, and a cancel button with a call confirmation light. The screw terminals are just like every other passive station, switch plus, switch minus, LED plus, LED minus. All of these devices can be connected, all these passive devices, including the dome lights, can be hooked to a control module. If you don't have a smart dome light outside the room and you just want to use passive devices for some reason to get creative, the CC2-CM4 is a 4-input, 4-output control module. 4-conductor passive cable to the passive stations. Exactly like I just showed you, this wire represents 4 conductors, and they are switch plus, switch minus, LED plus, LED minus on these screw terminals here. It connects to remote devices like annunciators with that 2-twisted pair, because the annunciator is a smart device and the control module is a smart device. It talks to each other, or they talk to each other over the 2-twisted pair network we talked about. So again, that same connector here has the same connector on the back of this station, and they just hook up T to T, R to R, plus to plus, and minus to minus. Pin for pin. No swapping, no changing, just T to T, R to R, plus to plus, and minus to minus. Here's another configuration you might see. If you've got a 2-color passive dome light, you might have one control module turning on the red light and another control module turning on the white light. 4 conductors out to that station to run the white light, 4 conductors from here to run the red light. Why 4 conductors? Because this light, although it's passive, it has to have all 4 conductors hooked up. Another configuration of these control modules, you might have a single 4-position annunciator that corresponds to one of these, and over here you might have another control module that talks to some other type of annunciator. You don't have to have everything annunciate to everything. You can segment it. You could have a 4-position annunciator that's exactly the same as this, addressed exactly the same as this 4-point control module. And then you could have a 16-point annunciator over here that shows all control modules. The wiring, again, is this 2-twisted pair from control module to control module, annunciator to annunciator, and 4-conductor wire out here to the passive stations. This wire, again, is plus minus switch, plus minus LED, and it goes on out to the dome light. Here's that exam office again, or clinic room space where you have the smart stations. But then look here, I've got a solid line going down to a push for help button. Why would you want this? So a lot of times they'll put this 4-button station and this dome light out in the hallway, but the doctor still needs access to a push for help inside the exam room. So we put one of our passive stations, hook it up with 4 conductors to the switch 1 input on the dome light. And every time this button is pushed, it activates that red light. Now, because these are addressed the same, it will also activate the red light on this station, on the 4-button station, which means you can cancel it from either the room station or the hallway station. But the wiring of this is 2 twisted pairs, your dashed line for communication between smart devices, then a 4-conductor cable from the passive station up to the dome light to connect these passive stations in each exam room. Again, in larger systems, you don't have any passive devices necessarily. You might just have nothing but network devices. And always remember to keep that power supply as close to the middle as possible. Let's talk about power. Power is a PS2437B power supply. You cut the connector off. I know it sounds strange, but again, this is not a UL 1069 listed system. There's no place to plug this power connector in the CC2 network. So what you do is you cut that connector off and you take your 2 conductors coming out of here. The center conductor is plus, the outer conductor is minus, and you hook that up to your power terminals near the middle of the loop. It's 24 volts DC output. It's 120 to 240 volt AC input, fully regulated, fully filtered, and built-in surge suppression. We don't want you hooking a lesser power supply to our devices. Our devices are designed to work with this fully filtered, fully regulated power supply. It comes with a wall mount bracket, so we make it easy for you to put this thing on the wall somewhere in a telephone room. You can power up to 30 CC2 stations. That could be either annunciators or room stations, combination of dome lights. So imagine you've got like a 16-room clinic with a dome light and a RS4 room status station, 4-button station, and then a couple of annunciators. That would take you to 32 plus 2 annunciators would be 34 stations. That'll work. 34 will work because you figure about 100 mils per station, and this is a 3.7 amp power supply. Okay. Let's talk a bit about the power required to properly run a CC2 system. That loop that we're talking about from station to station, you've got the twisted pair that is your data, and then you have your twisted pair that is power. Again, the wiring is plus to plus, minus to minus, T to T, R to R. There's no swapping of pairs. On the power pair, to know how much power is required, you take the current for each device, each station, you add it all together, and the total of that is the total power required. The total power available out of a standard TechWorks PS2437B is 3.75 amps. You want to keep a 10% margin for calculation, if nothing else, but it also is good so you're not right up against the limits of your power supply and having power supply failures, because the power supply will protect itself if it's overloaded. So the way to do this is to take your power supply of 3.75 amps per power supply times 0.9 or 90% of that power supply, which is 3.375. So the total of all the current required by all the devices should never exceed 3.375. That's approximately 30 devices, because typically each TechWorks device draws about 100 milliamps. So 100 milliamps times 30 is about 3 amps, give or take a little bit, but That means that somewhere between 30 and 33, 34 devices will work just fine on a TechWorks network on a single power supply. Voltage drop is a very big deal. So the resistance of the wire has to be taken into account. You can't just run these wires forever. They can't go a long, long distance, like 1,000 feet. 1,000 feet from the power supply. Your network data pair can be 3,000 feet of wire. Well, how does that equate with your power? Your power is going to be determined by the voltage drop across the resistance of the wire. See this R wire? This is greater than the resistance of the wire times 2, okay? So if you do the math, this will determine how much voltage is dropped. Now, the smaller the wire you use, the bigger the drop. The gauge of wire matters. We recommend an 18 gauge pair for your power pair. The data pair could be anything. It doesn't need to be high gauge because there's no current on the data pair. It's that power pair that's got to be 18 gauge. So 18 gauge works out really well. If you connect your power supply in the middle of your data loop, you have about 100 feet in each direction for a 200-foot loop, and you have plenty of voltage at the end of that data loop. The real danger is if you run too small a gauge of wire, that voltage drop turns into heat, which is dangerous, and it can cause a fire. Now, it won't cause a fire that will affect your customer, but it will cause a fire in the electrical box. The most of the heat is at the screw terminal. So what you'll find is if you ran too small a gauge of wire, you'll melt the screw terminals right off the back of the device. I've seen it happen. Not our fault. You got to run the right wire. If you determine that you need multiple power supplies, you don't hook them purely in parallel. What you do is you hook the plus and minus to a group of stations. You hook the common between all stations. So the power supply common has to be common to the whole system. It has to go from one section to the next. This is your common wire going from one to the other, going from one to the other. But your plus wire only goes to the stations in that group. Okay, so this power supply powers this group, this power supply powers this group, this power supply powers this group, this power supply powers this group. They all talk to each other as far as the data. You could have any station addressed to anything talking anywhere on this network because the data pair is all in parallel. But the power is dissipated over a small group and should be limited to about 200 feet. Now, you might get away with 300, depending on how long your runs are. But again, try to keep each leg of your power under 100 feet, and you'll keep this voltage drop down. You can add an IMR to this system. Why would you want to? Let's say that somebody wants text messages. In a clinic, a lot of times, getting that communication to the right person in a timely manner is the most critical part of the system. X-ray technicians are a classic example. They need to know where they're needed next. Text messaging can be the best way to go. IMR can do that for you. You can have a custom text message from every point in the system. This is literally a screenshot of my phone getting messages that exam room 158 is ready, 162 is ready. These come in the order that the button is pushed. So this would have been your first button push, second button push, et cetera, et cetera, et cetera. Any phone, any carrier. You can also do old style pocket page. You can do tablets. Digital signage. This is probably the most popular feature of the IMR because it puts a map of the facility up on the wall in the clinic so people can just glance up and know exactly where they're going. But again, this could be on your tablet. You could put this same map on your tablet. Any network, anything IP. So this is your IMR. It's this little box. You plug it into your network, however your network is structured, and your PCs become a display. So your PC terminal now becomes a display of this graphic, so you can find out where people are. They also become administrative terminals. If you have the user credentials to access the system and make changes, then any PC in the network can become an administrative terminal, but it's all controlled through the passwords. So your user credentials and your password make your access to the system unique. An IMR can hook to either a clinical system or a CC2, NC, or both. All you do is connect the IMR to that data loop that runs from station to station and annunciator to annunciator in a CC series, or from the annunciator line in an NC series. So it has nothing to do with connecting to the devices in the field or any passive devices. It's just connect to that annunciator line wherever you can with either NC or CC, and the IMR knows what's going on. It sits there and listens. It's a big listen box. Powered by 24 volts DC, so it runs on the same power. Literally, all you have to do is plug it in. There is a lot of programming that goes into making it do all the fancy stuff, but basic operation of an IMR is as simple as plug it in and it learns what's connected to it. We'll talk more about that in a presentation on the IMR, but the answer is yes, it can hook to any TechWorks network. Other tools available for you. We're available 24/7, 365 at www.techworks-usa.com. There's brochures for sales, specifications for engineers. We're always here to do design and quote assistance. Tell us how to help. For technical assistance, training and installation manuals are all available online. Please take part in the training and get a copy of the installation manual before you call tech support. We're here to help. We want to help, but it's so much easier to help if you've already got a copy of the manual, and even better if you've taken the training. Thank you very much for taking the time today. Next up is part 4, the programming of a CC2.